Okay, so we're going to look at problem 1.95. They give us two vectors in this problem. The vectors that they give us are this vector A and this vector B. Okay. And they tell us that there's going to be a third vector C. And it's in the xy plane, so it doesn't have any z components at all. We know that vector C is perpendicular to vector A. That's important. And the scalar product of vector C with vector B is 15. And if I take those two pieces of information together, I want to find out what the components of vector C are. Okay. So I can actually do that. It's not terrible. Okay. Well, the first clue that I have is this perpendicular to vector A deal. Okay. Well, if two vectors are perpendicular, then they have no scalar product. Remember, scalar product is to multiply the parallel components. So if it's perpendicular, then none of the components are going to be parallel. So what that means is that C dot A is going to be 0, or CX AX plus CY AY is going to be 0. Okay. Now we can plug our numbers in then. So we've got, because we have the information about vector A, so we can say CX times 5 plus CY times negative 6.5 equals 0. I'm going to bring the negative one to the other side, and I'm going to draw put the coefficients in front. So 5CX equals 6.5 CY. I'm going to divide both sides by 5. So CX is going to equal 1.3 CY. Well, it's not real useful to me yet, but it's going to be when I set up my other scalar product from the other piece of information that I'm given. All right, so again, we know that from the last problem, we had that CX equals 1.3 CY. Okay, I'm going to carry that around to get the next part of the answer. Okay, but the other piece of information, they tell us that the scalar product of C with B is 15. Now, order isn't going to matter in this case, but I'm still going to write it out. So CXBX plus CYBY, remember all of these don't have a Z component, is going to equal 15. So CX BX is negative 3.5 plus CY times 7, that's still right here, okay, equals 15. And again, I got two variables, but I do have something to help me. I got my secret weapon over here. So 1.3 CY times negative 3.5 plus 7 CY give me 15. So I add all those together. 3 times 3.5 is going to give me negative 4.5. So negative 4.55 CY plus 7 CY is 15. So I have 2.45 CY equals 15. CY is going to be 6.12. And CX is just going to be 1.3 times that. So that's going to be 7.96. So C is just going to be 7.96I plus 6.12J. And that should be the whole problem. That's the third vector that you're looking for. Remember, it's in the xy plane, so we shouldn't have a z component at all. Looks like we got it.